Welcome viewers. It is the part second of renin-angiotensin-aldosterone system. In the part first, we discussed about the release of renin from the body. In this part, we will discuss and other factors which are responsible for the release of renin. Again, here is the diagram. Last time we discussed this part. From where the renin is released. In this video, we will discuss the next part from which the renin is going to release. There are some other factors. Whenever your blood pressure is going down, suppose here is your heart, here is your carotid sinus. Carotid sinus is another place where blood pressure measuring device is also present. This carotid sinus has also the baroreceptor. When the patient is bleeding, then blood flow will at carotid sinus will be less. When the blood flow is less over here in the carotid sinus, the carotid system is also activated, and the special nerves or neurons report the CNS that blood pressure is falling. The nerve that is reporting that the blood pressure is falling is the 9th cranial nerve. It is also called the glossopharyngeal nerve. As soon as CNS senses that blood pressure is going down, it will stimulate the sympathetic outflow through the vasomotor center in the medulla. From the medulla, fiber becomes down. Neuronal connection will become down and stimulates the sympathetic outflow. This sympathetic outflow, which is going out through the preganglionic sympathetic and postganglionic sympathetic neuron. These are the preganglionic and these are the postganglionic sympathetic neuron. Here we will discuss only those sympathetic neurons which are going to the juxtaglomerulus apparatus. These sympathetic neurons which are going to the juxtaglomerulus apparatus release the norepinephrine. Baroreceptor cells have norepinephrine receptors. These baroreceptor cells have norepinephrine receptors that is called beta 1 adrenergic receptors. And you must know that the beta 1 adrenergic receptors are at the juxtaglomerulus apparatus, because beta blockers blocks them also and help in the hypertension management. So beta 1 receptors are stimulated. Here the beta 1 receptors are stimulated in the juxtaglomerulus apparatus and results in a more release of renin. It means there are two mechanisms of renin release. Number one is intrarenal. Number one is the intrarenal. Here number one is the intrarenal and number two is the extrarenal. Here is the extrarenal. This yellow one is the extrarenal. So, the functions of renin. What are the functions of renin? Renin is an enzyme. Definitely it works on substrate. Renin goes to the circulatory system. Renin goes to the circulatory system or the systemic circulation. You know that liver has lot of hepatocytes. It's a liver, lot of hepatocytes. Hepatocytes produce lot of proteins, normally albumins, alpha and beta globulins, but not the gamma globulins, because gamma globulins are immunoglobulins, antibodies which come from the plasma cells, that is the beta cells. Liver cells produce one special type of protein that is called angiotensinogen. Mind it, it is not produced in crisis but producing all the time in the body, all the time in the blood. Renin work on angiotensinogen. This renin work on angiotensinogen and convert it into angiotensin 1. When angiotensin 1 passes through the lungs, this angiotensin 1 passes through the lungs, it convert into angiotensin 2. It means in the lungs there is some enzyme which convert the angiotensin 1 into angiotensin 2. That enzyme is angiotensin converting enzyme. That is the ACE. ACE are present on the endothelial cell's surface. There is an other product in the blood that is called bradykinin. It is the bradykinin. Bradykinin is broken by the angiotensin converting enzyme and become inactivated. And you know well, bradykinin is a vasodilator and angiotensin 2 is a potent vasoconstrictor. One way round, bradykinin is a potent vasodilator and other way round, angiotensin 2 is a potent vasoconstrictor and ACE enzyme is responsible for converting the angiotensin 1 into the angiotensin 2 that is a potent vasoconstrictor and also inactivating the bradykinin. When the blood vessels constrict, the blood pressure increases. When these angiotensin 2 act on these blood vessels, they constrict and give the blood pressure rise. Now, in the next video, we will discuss about the functions of angiotensin 2. So, stay tuned for the more videos and the next video of renin-angiotensin aldosterone system. Thanks for watching. Thank you.